Hello, sir. Are they late or we just gave them a holiday for today?
I think they are late, say. I think they are late.
Oh,
Let me check.
okay. Not
I
a
think,
problem, sir. I will just try by all means to wait for them.
okay.
Then we will maybe extend the lesson with some 10 minutes after.
Okay, let me quickly check what's the status?
Okay, not a problem, sir. Hello, Lavela Kinene. I don't know if I pronounced your name correctly, but welcome to the lesson. And you are the first one and the only one who's already in the lesson. How are you doing today?
I'm good, sir.
Thank you, sir. Did I pronounce your name correct? Lavela Kinene.
Yes,
Oh, okay, man. I think since you're already here, we can just proceed and continue with the lesson. Uh, did you attempt the problems that I sent to you guys?
when, sir?
Uh, I sent them to Mr. Desmond and then he dropped them into the group. Did you see them?
Didn't see that.
You didn't?
Sir?
I'm asking if you did so, you did see the problems that were dropped into the group last time.
No, sir.
Oh, man, you need to keep checking after lesson in the group. There are questions that were dropped into the group, but then I can quickly share my screen. We can work together on them. Let me just share my screen like this, and then go straight to the question. So this is the question that was dropped into the group last time after the session that we had. So doing this question, can you see my screen that side?
Yes, sir.
Oh, okay, fine. Then let's just dive into the problem. So question 8 on this question is saying PON, almost said something. PON is a diameter in this diagram. Of this circle centered at O, the center of the circle is O. Okay. Then TM is a tangent to this circle at the point M. And a point, and a point on a circle. Okay, you noted that. R is another point on the circle, such that OR, we can see OR right there, is parallel to PM. NR and MN are drawn. Then now, let angle M1 be 66 degrees. Then I always recommend this. Always. This will help you a lot. DRCPT. Dr. Cape Town. So the diameter right there. So is there any diameter on the circle that you are looking on the screen now? Hello?
Yeah.
Okay, good. So if there is a diameter, which is this one, what can you say about that triangle, PMN, or specifically about angle M2?
There's angle 90.
Yes, that's correct. Let me just double check if it's still only you or there are other. Oh, there are others who joined us, Ethan Moore. I don't know if I pronounce your name correct, but I'm sorry if I pronounce it wrong. Thanks for joining this lesson. Let me go back. So we said there is a diameter, PN. Therefore, that implies that this angle right there is 90 degrees angle in a semicircle. Then we are done with that. Okay. Is there any radius, guys, in the diagram that we are looking at? Hello, guys. Can you hear me?
Yes, sir.
Oh, okay. Thank you. So, okay, you came late. We read the statement right there. PON is the diameter of the circle at O, which is the center of the circle. Then we're also given that TM is a tangent to the circle at M, which is the point on the circle. R is another point of the circle such that OR is parallel to PM. And R and MN are drawn. And let angle M1 be 66. Then as I said, guys, I recommend DRCPT a lot to this kind of questions. Dr. Cape Town, where D is the diameter, R is the radius, C is the cyclic chord, P parallel lines, T is the tangent. So my question was, is there a diameter? Then I was answered yes. That is a diameter PN. That implies that in the triangle PNM or PMN, however you can say that, but angle M2 is going to be 90 degrees, reason being angle in a semicircle, half circle, or angle subtended by the diameter. Then we are done with that D in the DRCPT. We can proceed to R, which is the radius. So my question to you guys was, is there any radius in this diagram? What's happening? You guys are quiet. Hello, guys. Where are these guys? Hello, guys. These people are here. So, guys, is there any radius in the diagram that we are looking at on the screen? Oh, my pet, I'm not getting any response. So, yes, guys, there is a radius on the diagram on the screen, which is this is the radius. Or let me just change the color of that. So we said this is the diameter. That implies that this angle is 90 degrees. Then going to R, dr, CPT. Going to R, this is the radius. This is the radius because remember, the radius is the line from the point of the center to any point on the circumference. So this is the radius. This is the radius too because the line from the point center to any point on the circumference n. Then this is also the radius. Therefore, this implies that in this triangle is an isosceles triangle because this line is equal to this line. Reason being, ready. Then we are done with this diameter, we're done with the radius. Then we can go for C. Is there a cyclic chord? No, there's no cyclic chord in the diagram unless maybe I can't see it. But if you guys see it, you can just let me know and shout it out. Then we go for P, which is parallel lines. We were given right there on the statement that OR, which is this one right here, OR here is parallel to PM, which is this one. Therefore, using a math is fun technique for corresponding angles, this for cointerior angles, and for alternate angles. We can see that this angle P is equal to that angle of 2. And again, this angle, if this angle is 90 right there, this one too will be 90 degrees, corresponding angles, or using theorem 1 that a line drawn from the center that intersects with that chord is perpendicular to that chord. It bisects that. And then going for alternate, is there anything that forms that? No, I can't find it. I can't see it. But if you guys see it, you can just shout it out. Then we are done with parallel lines. Oh, cointerior angles. This is 90 as well. Sum this and this, get 180. This and this, you sum, you get 180 degrees as well. And then we are done with P. Then you can go for T. And we can see that this is a tangent. This is the triangle. If we have this angle that is between the tangent and the chord is equal to the angle that is opposite to that chord that we are talking about, then we are done with the tangent because now there's no that theorem that we can say maybe a tangent is perpendicular to the radius. We don't have that. Then now we can just dive into the questions that you're having. They say now, calculate with reasons the size of each of the following angles. 8.1.1, we are required to find the size of angle P. And angle P, we can see that it's right here. We already found that using DRCPT. That is a tangent. This is the triangle that we are talking about. That angle that is between the tangent and the chord is equal to the angle in the triangle that is opposite the chord. Therefore, angle P is equal to 66 degrees, reason being tan chord theorem. Do you guys understand that's 8.1.1?
Yes, sir.
Okay, I can only hear one voice, and I think we have more than one people in the room. Do you guys understand that?
Yes, sir.
Yes, sir.
Okay. Thank you, guys. I would love to have your feedback, guys, so that I know now what to do. I'd like to know if you guys understand. I'd like if you guys don't understand, so that I can re-explain. And then now we can proceed to question 8.1.2, whereby now we are required to find the size of angle M2. M2 is right there, and we already answered that using DRCPT. What's the size of that angle, guys? M2.
90 degrees, sir.
90 degrees, reason being
Angles in a semicircle.
angle in a semicircle. 100% correct, sir. Do you all guys agree to that?
Yes, sir.
Yes, sir.
And do you all understand, or is there anyone who's still curious with that? Okay, I think all in the same page. Then we say there is 90 degrees, that one. Okay, cool. We can go to question 8.1.3. Now we are required to find the size of angle N1. And angle N1 is right here. This one. How do you guys think we can find the size of angle N1? Is there anyone with some idea of how we can approach this problem? Anyone, guys, who can give it a try? Oh, no, I think there is no one who is brave enough to give it a try. So we can see in the triangle PMN, we already have angle P, we found it, and then we have angle M2. So now we want angle N1. Do you guys agree if I can say angle N1 plus angle P plus angle M2 is equal to 180 degrees?
Yes, sir.
Yes, sir.
Why do you guys agree?
The
What's
sum
the
of
reason
triangle
behind
equals
that?
180.
100% correct. Yes. And then now you can just make that angle N1 be subject of the formula. You just leave it alone on the other side. You transpose the other angles, you're saying 180 degrees minus that 90 degrees of M2, and then minus that 66 of angle P. You're going to get that angle N1. Do you guys understand that?
Yes, sir.
Yes, sir.
Okay. Thank you. We can proceed to the next question, 8.1.4, whereby now we are required to find the size of angle O2. So angle O2, we were told that the line PM is parallel to line OR, and we already have that line. Okay, we have something like F here. This is parallel to that. We are given that. Therefore, we can conclude by saying this angle is equal to this angle. Reason being corresponding angles. Don't forget to state the parallel lines that line OR is parallel to line PM. Do you guys get that?
Yes, sir.
Yes,
Okay,
sir.
thank you. Sorry, yes? Oh, I
Yes,
thought
sir.
you asked. Okay, I thought you were asking a question. Then we can go to the last one now, whereby we are required to calculate the size of angle N2. Where is N2? Oh, right there it is, N2. So angle 2, this is a bit complicated, but simple for you guys as mathematicians. So we want that angle right there. And remember when we were starting attempting this question using that DRCPT, when we were on R, we said this is a radius. We said this is a radius. Therefore, this side is equal to this side. This is an isosceles triangle. Therefore, this angle is going to be equal to that angle. Do you guys agree to that?
Yes, sir.
Yes,
Okay.
sir.
Then we already have this angle right here. We found that angle as 66 degrees. Therefore, we can say this, we can let this angle right here, this one or any of the two between these ones, you can let it be x, such that we are going to have that angle O2 plus R plus, oh, that's an angle, or maybe that red R is going to disturb me. Let me just delete this and restart drawing this. So we are saying we are having this radius and this radius. This implies that these lines are equal. Reason being, Radi, then this angle is going to be equal to that angle. Meaning, if we let this angle be x, this too will be x, because those angles are equal. They are angles opposite equal sides. Therefore, we are saying angle O2 plus angle R plus O N R there at N. That thing as a whole gives us 180 degrees. Do you guys agree to this?
Yes, sir.
Okay. Then now we say angle O2, we know that this is 66 plus R, we said it's X, and O and R said it's X as well. Therefore, we say 66 plus 2X. Then when you get here, you can just transpose that 66 to the other side. You're going to have that 180 degrees minus 66. Therefore, you're going to have 114 degrees is equal to this 2x right there is equal to 2x, and then you divide by 2, you divide by 2. Therefore, angle x is equal to 57. 57. Therefore, this angle here is 57, and this angle here is 57. Do you guys understand that part?
Yes, sir.
Yes, sir.
Okay. Okay. Now, keeping in mind that we are not done answering the question, because someone can be like, oh, finally, I found that angle N. Then she's like, oh, I'm done. No, the question wants us to find the size of angle N2, which is that portion that is small, that side, and we already found angle N1. Therefore, angle N2 is going to be the whole of N minus angle N1 is going to be that whole 57 minus the size of this angle 1 that we found here on question 8.1.3. So do you guys understand this one? Or is there anyone who's still lost?
Understand, sir.
Okay, do you all guys understand this? So that we can move to the other questions?
Yes, sir.
Oh, okay. Then I think we are done with this one. Let me just try to go find some more of the questions. I can just quickly go to the files and go to the question papers, maybe attachments, and then what's attachments? I can just go to this one. And then, can you guys see my screen that side?
Yes, sir.
Okay, thank you. Then I have this question in front of us on the screen. Question 8. I would like us together to go through it. Then after we are done with this one, then you are just going to tell me how we can find these other questions to this 8.2. So with 8.1, we have that on the screen. Then reading the statement that we are given on 8.1 is saying in the diagram, A, B, C, D, the cyclic quad. Oh, that tells us something. We're going to use that. In the circle that have a center O, and the line ED, the line ED is a tangent to the circle at the point D. The chord AB, okay, is produced to F. There is F outside the circle. There, up there. Okay. Radii, which is the plural of the radius. So there are more than one radius. So radii OC and OD are drawn. Oh, gonna use that. And then we're also given that angle ADE, angle ADE, okay, right here, the tangent is 40 degrees, and you're also given that angle C2 is 65. So going to DRCPT, Dr. Krypton, I love these guys. So the diameter, is there a diameter, guys, in this circle? Hello, guys.
No, sir.
Okay, good. There is no diameter, then you can just sketch that out. We go to the R, which is the radius. Yes. On the statement there, we are given that the radii, more than one radius, which is OC and OD. This is the radius, this is the radius. That implies that OC, this line, is equal to this line, OD. Therefore, we can conclude by saying this angle is equal to this angle. Now we know that D1 is 65. We can reason that saying angles opposite equal sides. And then since again this is a radius, this is a tangent, we know that there's that theorem that is saying a tangent is perpendicular to the radius. So this is 90 degrees. Okay, we are done with that. C is a cyclic quad. We were given right here this, that ABCD is a cyclic quadrilateral. And we know that the properties of a cyclic quad can give us that. Let me just change the color to red. This angle right here, which is the exterior angle, is equal to the interior opposite angle, this one, okay? And again, we can say this angle plus this angle is equal to 180 degrees, or this angle here plus this angle here is equal to 180 degrees, knowing that opposite angle of a cyclic quad are supplementary, meaning they add up to 180 degrees when you sum them up. Then we are done with the cyclic quad. We go to parallel lines. No, there are no parallel lines, unless you guys maybe consider. And then there is a tangent. We were given that. This is a tangent. And then there's an angle there between the tangent and this chord. Okay, but then we can't say tan chord somewhere, somehow there in, because we don't have that triangle that is going to have an angle that is opposite to this chord. Okay, then we cannot use the tan chord theorem. Then we are done with the RCPT. Then let's dive into the questions. 8.1.1. They're saying determine giving reasons the size of each of the following. Now, what is the size of angle D2? Where is D2? D2 is here. To find that angle D2, because we noted that, or we know that this is a radius, this is the tangent to the circle AD. Therefore, this angle ODE is 90 degrees. Reason being radius of a tangent is perpendicular to, radius is perpendicular to tan, or tan is perpendicular to radius. Doesn't matter. So we want D2. We know that the whole of this angle is 90. We have got this portion D3 right here is 40 degrees. Then D2 is going to be 90 minus 40 degrees, which is simply going to be 50 degrees. Do you guys understand that, how we got that D2?
Yes, sir.
Okay, thank you. Do others understand that? Because I think I only got some feedback from one person. Okay, I assume they understand, because everyone is allowed to shout out if they don't understand. So we can move to 8.1.2. Now we are required to find the size of angle.
Yes, sir.
Okay, thank you, ma'am. Now we are required to find the size of angle FBC. FBC, which is that exterior angle of the cyclic quad that we were given. We said ABC is a cyclic quad. And then now how can we find that angle? Oh, this question is nice. So remember, we said using that DRCPT, when we got to that C, we said C is a cyclic quad. And then this is what we highlighted. We said the angle we said this angle is equal to that angle. Reason being, exterior angle of a cyclic quad is equal to interior opposite angles. Or this same angle is equal to that angle. Oh, no, they are not equal. When you take this angle, you add this angle, you're going to get 180 degrees. Reason being, sum of opposite angle of a cyclic quad are supplementary. Again, we come to this one, you add to this one, then you get 180 degrees. Reason being, opposite angles of a cyclic quad are supplementary. I think we analyzed enough. Now we can just answer the question, angle FBC. So let me just wrap this mess. So we are required to find this angle, FBC, this angle. How guys do you think we can find that angle? Do you guys have some idea of how we can find this size of this angle? Okay, to save some time, let me just try to work it out. Then what we are going to do, this angle is an exterior angle of a cyclic quad. That angle needs to be equal to this angle. Therefore, we can play around this angle. Then after we played around this angle, if we found this angle, this is equal to this. Since we are given that this is a cyclic quad, the reason is going to be exterior angle of a cyclic quad is equal to interior opposite angle. So how can we find this angle? Let's give it a look. So in this case, we found D2 as 50 degrees. Let me just write it there. We found that as 50 degrees, this angle. And then we used that fact that these are the radius, radii. Then we concluded by saying this angle is equal to 65 degrees, reason being opposite angles, opposite equal sides. So let me use different, no, it's fine. This is equal to 65 degrees. Therefore, now this angle CDA or ADC is equal to 65 plus 50 degrees. That's going to give me 65 or 60 degrees. Oh, it gives me 115. So it's 115. Therefore, now we found this angle here, is equal to 115 degrees. Reason being, exterior angle of a cyclic quad is equal to interior opposite angles. Do you guys understand what I did to find the size of angle FBC?
Yes, sir.
Okay, what about others? Do you guys understand it?
Yes, sir.
Okay, then thank you. We can just proceed to the other problems. Now with this 8.2, I would love to work with you guys. I don't want to do this alone, but I would like to discuss this one with you guys. They are saying in 8.2, in the diagram, the one that you're looking on the screen, O is the center of this circle that we are seeing. And then we've got those points on the circle are PS, and then OT. Here is OT. Here is OT. Here. Bisect RM with T. Okay, a point on RM. Okay, then PRM is equal to 32 degrees. SP, SM, radii. Okay. Oh man, OP, OM, radii, OP, OM, radii. Those are the radius. That implies that this is equal to that. Okay, at row. Then angle OMT, OMT is equal to 15 degrees. Okay, then going to the RCPT, as usual, the RCPT analyze, we highlight what can help us answer these questions. So D on the DRCPT is the diameter. Is there a diameter, guys, on the diagram that you are having on the screen?
No, sir.
Okay, there's no diameter. Thank you, sir, for the response. We can just cancel that out. Then the radius, okay, we are told there that OP and OM are radii. Therefore, this is a radius, this is a radius. This is equal to this. Okay, maybe that's going to help us. Then we are done. C, cyclic quad. Is there a cyclic quad? I don't think there's any, but if maybe I can't recognize it, you guys can shout it out. And then we can just sketch that out. We have that bow tie shape that we once talked about when we were talking about that theorem, angles in the same segment. We said those angles are equal, reason being angles in the same segment. Therefore, in this diagram, we can see that angle S is equal to that angle, and this angle here is equal to that angle, reason being angles in the same segment. Then, okay, we can go to P. There are no parallel lines. Scratch that out. T, there's no tangent. Okay, then we can just dive into the questions. Calculate with reasons the size of the angles. Now we are required to calculate the size of angle S. What is the size of angle S, guys? I think we found that. But now I want to hear from you guys. What is the size of angle S? With reason?
32 degrees, sir.
Okay, reason being?
Angles in the same segment.
100% correct. Do you guys understand why we say that angle S is 32 degrees?
Yes,
Yes,
sir.
sir.
Okay, thank you. Then we can proceed to question 8.2.2. Is saying now we have to calculate the size of angle O2. There is O2 right there. What is the size of angle O2, guys? The size of angle O2. Is there anyone with idea of how we can get the size of angle O2?
Uh, 64, sir.
64. What's the reason behind that?
Angle at the center is twice the angle at the circumference.
Okay, then now to others. Do you guys agree to his answer?
Yes, sir.
Oh, okay. Yeah, 100% correct, sir. Thank you for the response. That's 100% correct. Angle O2 is equal to 64 degrees. Reason being angle at the center is 2 times angle at the circumference. So now we go to the last one, 823. We want the size of angle O1, and there is O1 right there. There is O1. How do you guys think we can find the size of angle O1? Anyone with some idea, bit of idea of how we can get that? How do you guys think with this question? Can you guys see O1 in the diagram?
Yes, sir.
Yes. And then the hint is that we are given, in fact, we are not given, but we know, according to theorem 1, that if there is this chord RM, it also bisect, okay, OT bisects RM, then that bisector line is perpendicular to RM, meaning angle T1 is 90 degrees. That's a hint for you guys. What do you now think?
Angles of a triangle equals 180.
Okay. And then how are you going to find that angle O1?
We already said with theorem 1 that it bisects the chord OT, and we know that
Yeah.
that equals to 90 degrees.
Yes. Correct.
Then we
I
said
agree.
180 minus T1, which is 90, with M2, which is 15 degrees, which gives us O1.
Yes, absolutely correct, sir. Then that's 100% correct. Then, yeah, we are done with question 8.2. Any questions, guys, that you have regarding what we worked through? Or are you guys fine?
Fine, sir.
No questions.
Okay. Okay. Then we will jump that question 6.2 is a grade 12 Euclidean. And then we can come to this question 8 here. So we have this question right here in the given diagram. A, B, C, D, and E are the points on the circle. And BE is the diameter. Oh, is it? Okay, but you don't have a center. Okay, but it's a diameter. And the angle E3 right there is 62. Here is 62 degrees, not 62. It's 62 degrees. Okay, and the angle B1 right there is 50 degrees. Then BD is produced meets AE. They're saying BD, which is here, meets AE at F. Oh, this is F. Okay. And then now we can just use the RCPT to analyze the diagram. The diameter, okay, they said that is a diameter. This is a diameter. We know that this is 90 degrees. Fine. Is there a radius? We can't tell because we don't have a center, since the radius is the line from the center to any point on the circumference. So we can't assume that there is a center somewhere there. We can skip that. A cyclic quad, remember that a cyclic quad is a quadrilateral with its 4 corners on the circumference. Then 1, 2, 3, 4. What is it? 1, 2, 3, 4. This is the quadrilateral with 5 corners. It can be a cyclic quad. But this is a cyclic quad. This one is a cyclic quad. Okay. Therefore, since that is a cyclic quad, this angle this one is equal to that angle, reason being exterior angle of a cyclic quad is equal to interior opposite angles. Okay, and again, this angle is equal to that angle as a whole. Exterior angle of a cyclic quad is equal to interior opposite angles. And then this angle plus that angle right there should give us 180 degrees, and opposite angle of a cyclic quad are supplementary. Same applies with this one and that one. They are supplementary. Okay, we are done with the cyclic quad. Parallel lines, there are no parallel lines. A tangent, there's no tangent. Oh, fine. I also can see other cyclic quad. This is a cyclic quad as well. This angle plus this angle is equal to 180 degrees. This angle plus this angle is equal to 180 degrees. Okay, done. We are done analyzing the diagram, so we can just dive into the question. Determine with the reasons the size of angle BAE by which is that angle right there. By that angle. How do you guys think we are going to find that angle? Anyone with an idea, guys?
Angles in a semicircle equals to 90 degrees.
Oh, okay, 100% correct. You can get the full 2 marks. Do you guys understand why we say angle by is 90 degrees?
Yes, sir.
Okay, thank you. That is going to be 90 degrees because we were given that BE is the diameter in the diagram. Then moving to 8.1.2. And then we are having the question that requires us to calculate the size of angle E1. E1 is that one right there, this one. Anyone with an idea of how we can get that angle E1, guys?
We can use the sum of angles in a triangle.
Okay, which triangle? ABE, right?
Yes, sir. So
Oh.
say 180 minus 90 minus 50, we get 40.
Okay, and then you left your reason?
Yes, sir.
Yeah, and then you're gonna say sum of interior angles of a triangle are supplementary. Then we can proceed to angle C1. C1 is this one right here. How do you guys think you're going to find the size of that angle? C1. This is a bit complicated. Okay. What do you guys think? Anyone with the idea, guys? Of how to get the angle C1?
Angle C1 equals angle E3.
You are saying angle C1 is equal to
E3.
reason being
Angle subtended by the same arc.
by the same.
Wait, no,
I beg your pardon. Can you just please repeat what you said? I didn't hear you well. You said this angle. Sorry. You said this angle is equal to that angle.
Yes, sir.
Why and how? Because we need the reason behind the statement. So why are you saying angle C1 is equal to angle E3? What did you say your reason is? I think that's what I didn't hear when you said it.
Yeah, I think it's wrong.
Oh, okay. We can just think of other approach. What do you think? What do you think after the analysis that we had, guys? What do you think? There should be something maybe by now in your mind. You must be thinking of something.
Since angle A is 90 degrees.
Angle A, okay. You are saying since this angle is 90 degrees, okay.
Angle C and B can also be 90 degrees, and the reason will be angles at the center.
You are saying angle C and angle B are 90.
Angle C and angle A.
You are saying this is 90.
No, angle C will be 180.
Angle C will be 180.
Yes, sir.
So you mean the size of this angle, if I hear you well, you mean the size of this angle is 180 degrees?
Yes, sir.
Oh, I disagree, because remember, the angle that you are saying is 180 degrees is just a line. So can you see that this is not a line? They've got an angle here. So I somehow disagree that angle C is 180 degrees. Do you understand what I'm saying? Do you understand my contradiction to your statement?
Yes, sir.
Oh, okay. Thank you. Then we can try another approach. We can try another approach. What do you
Sir?
guys think? Yes,
Sir?
sir.
A equals to C, and both of them need to be 180 because it's a cyclic circle.
Oh, sorry. You are saying to me this angle is equal to?
90.
Yes, this is 90. I agree. And then
Maybe C equals also 90. The whole C.
you are saying to me this is 90. Reason being?
Cyclic circle. Both angles has to
So,
equal to 180.
okay, I see that. Which cyclic quadrilateral are you referring to? You mean this quadrilateral?
Oh, my bad, sir.
So you now see that this is not a cyclic quad. So you can't say angle A plus angle C are supplementary, because
It's not
that is not a cyclic quad. It has got 1, 2, 3, 4,
the
5 on
pentagon.
the circle. So that's why we said the cyclic quads that we are having is this one. Okay, 1, 2, 3, 4, and this one right here. This one here. And this one, I didn't see this one. There's this one too, right here. Can you guys see that?
Yes, sir.
Yes. So we can just give it another try. How do you guys think? We want the size of angle C1. C1 is right here. We want C1. Boom, 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 boom. Boom, 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 boom. Okay, that will be homework, guys, to go find it. We can just save time and pass to 8.1.4. Find a size of angle C2. How do you guys think we can find the size of angle C2? C2 is right here, this one. What do you guys think with that one? Is there anyone with some idea? Hello, guys, are you still there?
Yes, sir.
Okay, so I'm saying just to save time, let's say that C 8.1.3 will be your homework. We'll just go find that at home. Now to save time, let's find the size of angle C2. C2 is this one right here. Let me just highlight it. That one is C2. We want the size of angle C2. How do you think we can find the size of that angle C2? Oh, this one I think is simpler. I think this is simpler, guys. What do you think? You guys still can't find this one, eh?
Yes, sir.
Okay, then what about 8.1.5? Then it wants ABD. Where's ABD? ABD. Oh, nice one. Okay. Then what about ABD? Can you find that one? Is there anyone with an idea? Oh, okay. Let me do this. Okay. We found this angle, right? It was 90 degrees. You said, and we found this here. Let me do this. I love color red. We said this is 90. We found this. I don't remember. We found that as 180 minus 50 minus 90. We said that is 40. Okay. Not 46, but 40. And then, okay, we found this. We found this. Now we want this. We want C1. Giving you guys a hint. I mean, you can just see what you have and see what you are looking for. We are looking for this angle, right? So I'm saying to you guys, I'm giving you the reason. Angles in the same segment. That is going to be your reason. Now I'm asking you the question, what is the size of angle C1? You still guys cannot get it?
40 degrees, sir.
Sorry?
It's 40 degrees.
Yes, it's 40 degrees because, okay, then let me say, we have this diagram right here, the one that I was talking about, the bow tie one. This angle is equal to that. This is equal to that. Therefore, this angle is equal to that angle. Then C1 is equal to 40 degrees, reason being angles in the same segment of angles subtended by the same chord, angles subtended by the same arc. It depends which one you prefer. And then 8.1.4 is saying calculate the size of angle C2. Now we want this one right here. How do you think we can find this one, guys? This one right here. What do you think? Anyone with some idea? But this is the hint. This is the cyclic chord. This is the line produced from AE. This angle is equal to that angle. What do you think, guys? I gave you some hint. What do you guys think? Do you guys agree or disagree if I say this angle is 62 degrees? This angle, I'm sorry for this, let me just reject this code. I'll get back to her later. Do you guys agree or disagree to that? Sorry, not. Do you guys agree to that? Me saying this angle right here is equal to 62 degrees. Hello, guys, are you still there?
Yes, sir.
Okay, so I'm saying now that angle ABD is 62 degrees. Now I'm asking if you guys agree or disagree to that.
You explain it again, sir. Like, why is it ABD 62?
Oh, no, I'm just saying because I want to know now if you guys agree. I want to know the reason behind that. Do you just agree or disagree? Or you don't know? Can you guys notice that this is a cyclic chord? Can you
Yes,
see
sir.
that?
Oh, yes, sir.
Okay. Okay. Then we have got this line here. Can you see that line? So now, do you agree if I say this angle is equal to that angle, reason being exterior angle of a cyclic chord is equal to interior opposite angle?
Yes, sir.
Okay.
Yes, sir.
Then now that angle ABD is equal to 62 degrees, reason being exterior angle of a cyclic chord is equal to interior opposite angle. Then we can say, okay, that is 62. Then we can say B2 is, no, I don't even think we need B2. But can you guys see this diagram right there? Then now I'm asking you, what is the size of angle C2? We used this theorem a lot, especially today. Can you guys see this diagram that I've drawn on the screen?
Yes, sir.
Yes. So now we know that this angle there is 62 degrees. Then now, what is the size of this angle right here? Isn't it 62 degrees? Angles in the same segment. Can you see that, guys?
Yes, sir.
Yes, sir.
Yes. Yes, angle C2 is 62 degrees. Angles in the same segment. You get it?
Yes, sir.
Okay. Is there anyone who's still lost with that finding angle C2? Or we can proceed to angle 8.1.5.
Next question, sir.
Okay. 8.1.5, we are required to calculate the size of angle ABD. There's a B, or ABD is this one, and I think we already got that. You can just say this is 62 degrees on this cyclic quadrilateral. This is exterior angle. This is interior opposite angle. Then angle 8.2 requires you to complete the following theorem for the statement. The angle between the tangent of a circle and the chord drawn from the point of contact is equal to what? Sorry?
What?
Were you responding to the question or? So 8.2 is for you guys. You can just go look at it from the textbook. It just says the term chord theorem. Then it is wise for you guys to know those theorems because yes, you can see it can be assessed that you sometimes are required to complete the missing statement. Then I will just pick some questions that I will send as some homework in order for you guys to get comfortable with these Euclidean problems. I will just send this question 8 and this question 8. And this question 8 as well, especially that 8.2 questions. Interesting, because maybe with the upcoming lesson, we will focus more on these questions that are requiring us to prove some things, because I think we did a lot this question that wants us to find the size of some angles. So guys, any question regarding what we did tonight? Or we are all cool?
All good, sir.
Okay, thank you, sir. So also others are fine? Or is there anyone with a question?
All good, sir.
Okay, then thank you. I think this is the end of the session for today. Thank you for being with me tonight, guys. Have a good night.